I'm very happy and pleased to be here. Actually, this is becoming feeling like coming to home. I think this is the 4th time this year I'm here in Umeå. And I'm brushing up my Swedish also. I can understand Swedish, so be careful. But my talk is rusty. Being over 10 years in US, you don't really need very much Swedish. I'm going to talk in general about aspect which is actually relatively under-researched until recently. Especially people who are interested in innovation and who are interested in new type of change in business activity or any type of organizational activity. And that's the role of the new type of technological capability which we can call digital technologies in influencing and shaping the way in which both innovation outcomes and the processes of innovation. Just one example of that. If you write digital innovation into Google, at least a year ago, the first hit which it got was a course which I taught in University of Jyväskylä in 2008 on digital innovation. There are no publications, there are no books on that topic. Very little, which I found very surprising. So that typically shows, at least for scholars, it's a cool term. So there's a lot of opportunity for publications and making your name, sort of putting your stand on the ground in the sense that this is my term and I've invented it. But it also sets up certain types of challenges which I'm going to talk very shortly. Now, if you look at the nature of innovation today, you can clearly see that it's very different from the innovation in the past. I'll provide a short example, which is the mobile telephony. Just I think about 2-3 months ago, this guy, he was one of the inventors of the mobile phone. He worked at Motorola and was part of the team which moved from AT&T in 1947 when the idea of cellular telephony was invented and developed one of the first technologies for mobile telephony which were ready actually in early 70s, and this is from early 70s. It's one of the first mobile telephones, and it's a clear, clunky thing at that time, and it's analog technology though. And this was led then actually to which was in the Europe or Nordic countries known as NMT and the US known as AMS technology. Then digitalization came, and you could see that the phones became much more smaller and slicker. But basically they looked very similar. They had the same functions and the same idea. And then around 2000 or a little after that, 2004-05, we started to see very different functional forms and very different nature of mobile telephony. As I spoke with Joni yesterday, it's very difficult to say whether this is a phone anymore. It's something which you carry with you, which has a phone functionality. Actually, it's a computer, full-fledged computer with all the capabilities. A computer out of which one capability is the idea of voice communications over distance when you are moving. But you can do a lot of other things with it. It can provide you guidelines how to drive in the city. It can give you information what is available in a certain location in the city, and how to find certain types of resources or activities in the city, because it knows where it is. It can help you to find your car if it's stolen, if you don't know where it is. You can play games with it, and you can make, of course, money out of that, as you probably know from Angry Birds. You can read books with it. It can serve as a clock, and this was already early, or it can give you an idea of what's the weather pattern. It can follow you up around and tell you what is your heartbeat rate, or what is your blood pressure. It can be attached so that you can start measuring blood pressure. It can follow over time your biorhythms and provide you some guidelines how to sort of react to certain environments. It can be actually a user interface for your car, and there are currently cars sold in the US where this is one additional feature. This is a wiper from Dodge, where you can do all these things with the smartphone. You can go to a shopping mall and read the tags and find out whether there's somewhere else a better deal for this item. You can use it as a measurement device if you're a very enthusiastic carpenter. You can pay with that. This is, of course, US because they have this idea still that you need checks, but you can actually write and read checks and upload them and accept them. Then, of course, as part of that, if you look at the types of things which are similar and have all types of digital capabilities or are influenced by that, these are just examples. Buildings look very different because of digital capabilities. On the left, that's the building where I work. That's Peter B. Lewis building. It's a building, it's not a sculpture. And then cars are very different nowadays. They're becoming very different in the next 5 to 10 years. And there's a lot of other stuff which our environment will be very different in the 5 to 10 years. And it also shows that the type of knowledge which is integrated into these devices, and if you look at the range of knowledge which is integrated into the types of things which you can now do with your mobile phone, it's just amazing. The types of communities which are brought together. So, we can say that there is probably something very different and interesting in these types of things. And there has been some this interest in this idea of digital innovation. In principle, it's a fairly simple idea. It's that you do something new or different, which didn't exist before, at least locally or globally, by the application of digital and communication technologies. And in principle, it means that you embed these types of computational solutions and related artifacts into the innovation process outcome. And these are digitally enabled computational processes, not analog. And there are sort of things which this implies. The first and most important one is that you come up with a new type of content and capability. For example, the idea that you know exactly where you are located, and based on that you can say how to get to another place. It requires a fairly complex algorithm to figure that out. A lot of information from many different places. It may require a new type of architecture like web services, or new types of protocols, which you typically find in the lower levels of internet stack, which are currently being worked. It may be a new artifact, like the beauty of iPhone. It's a part of the digital innovation. It may be also changing the states of beliefs. For example, the way people have to think about innovation processes are very different now because of this digital capability. And the fact that we can integrate so much knowledge so easily into this process brought to bear upon this process. And we can see very different observed behaviors. I just today read a study carried out in England. So those people who do MRIs, they scan your brain behaviors, the electromagnetic behaviors in your brains and what parts are activated, and they found out that people who are using actively Facebook have a very different patterns of behaviors than those who don't. I don't know whether it's a good thing or a bad thing, but there are some changes. So if you look at that, there are a lot of things which actually come with the digital innovation. It can be seen in new types of products and product capabilities. The integration of products with services, as they call the servitization of products, which also means that services become actually commodities to some extent. There's a lot of things which happen during the adoption. It's not anymore that the product is as it is for the whole its life cycle. It will actually change a lot over its use, because from the use you can use processes introduce new types of innovations. And the diffusion processes may also require new types of capabilities. This leads to this idea of digitizing and digitalization. The fundamental reason why this is different is that we have to understand differences between analog and digital. Although this looks very simple, but it has significant influence. The idea of analog, which we have been living around from late 80s and when the invention of electromagnetic capability, is that you actually, like voice, which I'm not talking, it's some sort of amplitude variation. And that's recorded in some way in some other analog form. And then it can be inscribed into certain types of material technologies, either in an amplitude in a radio wave or in something like LP record or magnetic tape or something like that. And then what this has resulted is that we have a lot of different types of technologies for inscribing and representing information in different forms, from telephone to photography to movies to books and newspapers and TV. This is the world which was very common in 70s and 80s and 90s, and it started in 20s. And the important part of that is that each one of them is a separate, very siloed technology and related industry. Actually, we talk about these as industries. And if you look at these types of industries, these are very highly vertically integrated, very tightly coupled. So the industrial structure, the organization, and the forms and means of representing information imply a very tight coupling. So, and there are several reasons for that. For example, there are high-cost, fixed-cost infrastructures. For example, if you want to start a printing press, you have to invest huge amount of money to the distribution, to the printing, and all that stuff. If you want to start a recording company, you have to invest a huge amount of money into recording studios and distribution channels, and so on and so on. Typically, information was concentrated on a very few hands, and there was even an incentives to hamper additional innovation. For example, it was very long time known that you were not allowed to connect other devices to phone networks. Actually, it was denied, or it was not allowed. For example, AT&T in the US allowed that only in late 80s. Before that, you could only have devices which were produced and manufactured by AT&T. The same was in Sweden, if you can remember. Some of you are of that age still that you can remember what happened in the 80s. On the other hand, what we also observed at the same time was that the consumer market was mass market. Mass market needed, and because you need to masses to provide economic return on these fixed asset investments, high fixed asset investment. There were very little niche interest. You had a standard service, and that was what everybody got. Pretty much the same. And there was a very strong hand of the regulator, because certain things like radio waves or who can set up telephone lines into certain parts had to be heavily regulated. And now if you look at digitizing, the start point is very similar, but when you get the analog signal, you have some sort of device in between which actually transforms those into numbers. And the numbers are zeros and ones. They could be in principle any numbers, but zeros and ones are good because they're very easy to represent in any physical device as a state that something is on or off. And then you can, when you store into those forms, you can map them back to some type of transformation process which is similar to the original information. Now, this can be done to any type of information, and it has a very significant impact on the way in which the information actually is used and manipulated and resulting industrial structure. The first one is that the idea, now the information is totally immaterial. It is actually separated from the material carrier. Any material carrier which can separate between zeros and one can be used to represent this digital information. So you decouple innovation in the how to store and manipulate information from the idea of information itself and what that information stands for. So there's no physical mode of being for the information anymore. It's just bit strings. And any information is just bit strings, as long as we can agree what that bit string means. Thereby we also separate the interpretation from what the information itself is. And those are just carried in fixed multiple carriers. The second one comes from Claude Shannon's digital signal theory. When I was in 70s and 80s, we thought that this was one of these American technological, I would say, like imperialists who just thought about very narrow terms about information. But I think he had a very important insight. And the most important insight is that when you look at information as a digital capability or digital encoding, it provides you a unified theory to think about how to transmit information and what is the most efficient way of transmitting information. So as a result of that, the Shannon's theory separates the content and medium, or the capacity to send a certain bit stream and how effectively you do that from the content itself. So you don't have to anymore think about that. You can have just one channel in which any type of information can be sent. it leads to the idea that all data is homogenized, as long as you can just transfer it over the network. And principally, actually, Claude Shannon was one of the first ones to really predict, if you read some of his work, that the idea of this type of what we now know internet. The idea that there's a general purpose communication network which can transmit any type of information. And we can build this type of capacity. Another important aspect of digitalization is von Neumann's computing architecture. And it follows from the idea of digitalization or digital computing. The idea in von Neumann's architecture is that actually the behavior of the computer can be also represented as bit streams. That's the software. That's the software which you run. And when you change the software, you change the information in the computer storage, which guides the behavior of the system. You can reprogram that computer to do any type of thing. So the computers become, in this way, general-purpose technology. They are not just a phone or something else. They can be used for anything. And behavior at the end is just another bit stream. So the behavior is separated from some material carrier. It is just information as in any other type of information, as long as it can be understood and mapped into some physical substrate. So with this, you get this important idea that you separate the physical device, which is the computing terminal, from the logic of the service. And the fourth one is the self-referential nature of the digital computing, which is that the production technology and the use technology are exactly the same. This is not typically the case. If you go look at the car, you look at the car industry or manufacturing site for cars. The manufacturing side of the cars is very different from the car itself. But if you look at sort of how people develop new computer capabilities for software, you use the same device to generate new behaviors. So which enables that you can actually move the capability of innovation to anywhere where you have a computer. And the other aspect of that is that bit strings can be used to describe other bit strings, which makes it possible that it becomes reflexive, the technology. So the technology itself can describe itself. And this is very fundamental for certain types of ideas which you currently see in internet, for example, XML, if you know what that means. But it basically is a way of representing the semantics of the bit strings in the same bit string which you move along in the network. And this is very important for flexibility, which you apparently get in the network. And the last one is that you use the same technology actually for the diffusion and learning. That's the reason why we see so fast diffusion rates now. That the technology itself becomes the platform for diffusing that technology. Now, when you look at all these things together, what we have currently is the fundamental thing is that what is happening is this that we are shattering the tight coupling between the information transmission, storage, and manipulation, which we used to have with analog technologies. So you can use, which IBM actually calls 5 A's, anytime, any place, any device, any user, and blah, blah, blah. That's what you get with that. And any type of service. So, and what is important here is that it has the potential to dissolve the boundaries between industries and capability and structures, which we are currently seeing, and we will hear more about that in the next talk. One example from the printing industry. And this has been happening in many fields. I call this as digitalization, which is not, when you start using these digitizing technologies, which has the potential to shatter or decouple the information and its transmission and storage from a certain type of devices or capabilities, I call it a digitization. So it's a socio-technical process because you have to also look at the social context, industrial organization, IP rights, all sorts of things into the right, what really is possible. But if you look at the situation, this has happened in telecommunication industry. It's started to happen in the 70s, music in the 80s, TV in the 90s, books in 2000, e-readers, and the cars. It started actually happening in mid-90s, but it's still ongoing, and it will be much more faster in the next 10 years. Another part of that is if you look at the evolution of this digitalization, there are two stages. The first one, which I call the cowpath stage, which was pretty much that we digitized things which we knew already how to do. For example, Nokia's GSM phone is a typical. It's a phone, but it has a lot of digital capabilities. The same with DVD and so forth technologies. And this was largely a change in quantity. You just get more with the same cost. A little bit better quality, but the same stuff. But the reason why we are now in a very different stage is that the cost of microprocessors, the cost of memory, the cost of transmission, all these have gone down exponentially and still continue to go down exponentially. And as a result of that, we are actually currently seeing, the reason why we have this turmoil is that we are unleashing the flexibility of this digitizing capability. So we are using the low-cost computers to use this type of devices in pretty much everywhere. If you go and look at a typical car, it has about 60 to 70 computers currently on board. That's more computing power than in your desk. So we have these cheap digital processors everywhere, and that we call device convergence. At the same time, we have seen that different types of networks can be now communicate with one another, and that we call the network convergence. And these have happened largely actually already sort of in the 90s and early 2000s. But when this radical digitalization is happening as an outcome of those two types of processes, I will skip this because we don't have time. We are seeing up a very different way of building infrastructure and what I call the digital convergence, which is the following. That when we have had this device and network convergence, so in the late 90s we had the flexibility and increasing capabilities reached a certain type of tipping point. You had enough, it was cheap enough and you had enough capability. And you had these devices which now could be connected to an internet network. We started to see this with people now called market convergence. So you have these unusual deals. That for a typical example is Apple. Apple is a computer manufacturer, but actually it becomes a music distributor. Then it becomes a phone manufacturer. So it moves from one industry to another industry. And the borders between these industries have disappeared largely. And this is exactly the outcome that we have this very loose coupling now between devices, networks, and types of influence. And those who can build adequate or winning types of combinations, how to combine devices, networks, and types of information are the ones which actually are successful. And this is the new world where we are living as a result of it. So we have these things which didn't exist like 10 years ago. Most of them didn't exist at all. I think the oldest one is probably Amazon, which started in 1997. And these are all currently large companies. And these reflect real qualitative change in the way in which these industries operate and how the business is run. And we are moving to this type of paradigm, which we call the digitally networked paradigm. We have very low fixed cost because we can use the same computer pretty much everywhere. There's no central control. Anybody can, in principle, innovate because anybody who has a computer can innovate. There are very little gatekeepers. There are no permission needed to design and deploy an application. And we are seeing this type of defragmentation of the markets and needs. So you have to serve niches, and you have to understand those niches. This is the basic idea if you have read the Chris Anderson's book of long tail, that you make money in the long tail. Those things which very few people need, but because you have access to those and you know what their needs are with low cost, you can serve them well. Amazon is probably, and Netflix are probably the best examples of business models which are all based on that. So this is an outcome of digital convergence, which must take into account both the production and distribution networks. And this has resulted in very different types of environment in which we operate. So we can operate in small groups over the networks in different configurations. We have very alternative production processes. I'll talk a little bit about that later, especially in the innovation. And we have very different key enablers. Open networks, largely cheap or free software, and low fixed cost required to participate in innovation processes. So this has resulted in a very new state of the play for innovation. So you have to really very different way of aggregating resources for innovation in this space. And you have this idea, which is people call generative in this new environment, which is basically that if you can recombine capabilities which you have at place in new ways, you can generate very new types of things. And I'll show you some examples of that. Much of that comes from this idea that traditionally you describe any product as a hierarchy. Components and subcomponents. Like if you think of a car, it has an engine, a power axle, tires, body, and so forth. These were different components, and they can be subcomposed. And then you know that how to put them together, and you could produce them. Now, if you look at the way in which like Apple's iPhone, it has a contents and service layer, which is the apps which you do, and the content. Below that, there is some sort of network layer, which is run by the radios and other things which you do. And then you have the actual device, which is the computer. Now, these are only loosely coupled, which means that you can use different contents for different types of networks, for different types of devices. You can run the same application, not only in Apple, but on other types of devices. So these are very loosely coupled, this relationship between these different layers. So I'll also show you somehow this, and this enables a very different way of generating capabilities and innovating. I'll provide one example of a product, this is from how this idea of these map applications, or location-based applications emerged. Originally, the very simple idea which you wanted to serve is the idea that you want to move from point A to point B. And how do you provide support for that for the user? Who has maybe need some sort of support over the network. So Google in 2003, I think 2004, introduced that this new service was Google Maps, which is basically a very fixed service by which you could get that information. You say that I want to go from point A to point B, and they will provide your map and all that stuff. You have always used that. And they announced that at that stage. Then one guy from DreamWorks, Paul Rademacher, who was a software engineer, looked for his own house using Craigslist. And he thought that you could just see the addresses of the places. It would be very good because he knew the Google map. Why can't I put those addresses in the Google map and see where they are in the city? And he built this application in a fairly short period of time and introduced it in Craigslist. And people said, this is really cool, I can do it much better. So you could start seeing where these different addresses are and use that as a part of the Craigslist. Now, Google learned from that, and then it built an API interface, which was a JavaScript-enabled Oyster. So you could actually start building these types of applications on Google Maps, because this one person started it. And then they announced that this is like your Oyster. Then other ones followed. So if you look at now, there are Google Map APIs, there are Flickr APIs, there are Facebook APIs, and the Twitter APIs, which can use different types of house mapping, photo maps, Facebook, and other types of things together. So you have this very complex network of different types of things which are providing different similar types of service on different platforms. And in principle, if you are using a device, you could in principle use all of them. But you have this capability to generate new types of applications now because of this availability of these APIs, and as people call the mashups. One thing which we have pointed out here is this idea that actually you can think it as a genetic, that you have the genes which are these capabilities which you can combine in new ways to generate new types of species. And we are actually using DNA sequencing techniques to study these types of evolutionary processes, how new species emerge using these types of techniques. And in a way, it is like genetic programming, that you could say that we have this potential to generate infinite varieties of different types of services because of these types of capabilities. And it leads to a new idea of different types of structures which are needed. Another aspect of that, which I will finish, is that this has had a very significant effect on the way in which we have to think about innovation. We studied architecture mostly, but we have recently studied also chip designs. We have studied also software and car design. And there are certain principles which emerge nearly in all situations. The first one is that we are seeing this separation as an outcome of digitalization of two things. That knowledge becomes distributed widely across different networks. It's not anymore owned by one company or even a couple of companies. It's everywhere. Users, a lot of different types of things. And you have to be able to tap into that. And digital capabilities offers you that capability. The other one, why we say doubly distributed, is that the control has also become distributed. There's very little innovations where only one single firm or actor controls the whole process or has control over all the outcomes. So you have much more complex dynamics play in these types of situations. The other one is that there are multiple ways of making sense of this innovation, which we call models. So the sense-making and understanding what this is about is very important. Because typically you generate something which didn't exist, you have to generate meaning to it, and you have to understand what it is. The third one is that we've seen shift in organizational forms, which means that typically the innovation goals or the process drives the organizing, not the other way around. It's what you want to deliver and how you want to deliver it. That typically determines the organization, not the other way around. So thinking that you have a PMI, project management book, and by then you run your innovation process is doomed to fail. The third one is that this idea that the networks, they are not only divergent and diversified, but they are also what we call rolling, which means that they tend to expand even during the innovation process and over time. And you have to have this capability to integrate and assimilate and somehow have new ways of integrating these type of ideas and the participation into this network. The next one, which I call cascading innovation, is which actually we found from a study of Frank Gehry's couple of construction processes. We found out that they started with innovation with using three-dimensional modeling techniques to capture the design intent of the building. And they used that in the construction. But that led to the innovations in construction processes, risk and insurance, project management principles, manufacturing innovations, and so forth. And there was this type of like a dance or cascading innovation between one innovation led to another innovation, which led to another innovation. And typically, if you get this type of, if you say, innovation process going, that's what you want. But it's not necessarily always easy to do. And the last one is that even though much of that is dependent on digital innovation, there is this important aspect of material aspect which always constrain or enable the innovation process, and you should not forget. That's the idea of binary. That it's a binary world. You have the digital capability, but you have to anchor it or see how it's enabled by material capabilities. You need face-to-face meetings. You need to build trust many times. You need to have material ways of representing and understanding certain things which are outside the digital space. And the real interesting challenge is how you do that. We don't know that very much because the digital capability is so new that where it works and where it doesn't.